A bottle of Pennzoil 5W-30 and a bottle of Pennzoil 0W-20 are not the same product in different packaging. They perform differently at cold start, differently under load, and they belong in different engines for reasons that have nothing to do with which one costs more. The common assumption is that 5W-30 is the heavier duty option, and 0W-20 is the economy choice. That assumption is specifically what Toyota, Honda, and Ford have engineered against. The two numbers on a motor oil bottle describe two different physical behaviors. The first number, 0W versus 5W, describes how the oil flows when the engine is cold. 0W reaches the bearings faster at cold temperatures than 5W does. That matters, because the majority of daily engine wear happens in the first seconds after a cold start, before oil pressure builds throughout the lubrication circuit. A faster flowing cold oil shortens the window where metal moves against metal without a film between them. The second number, 30 versus 20, describes oil film thickness at normal operating temperature. This is the number that controls protection under load. A 5W-30 is thicker at operating temperature than a 0W-20. But thicker is not better here. Thicker is only better in the engine that was engineered to use it. Two practical problems come from using the wrong grade. A 5W-30 in a 0W-20 engine creates more internal resistance than the oil pump was sized to handle at full flow. The engine loses measurable fuel economy. More importantly, if a wear claim is submitted under a powertrain warranty and the service records show the wrong viscosity, the claim can be denied. Manufacturers specify oil grades as part of the engineering design, not as a preference. A 0W-20 in a 5W-30 engine reduces the oil film at operating temperature below what the bearing clearances were designed around. The gap between the bearing surface and the journal is wider in an engine built for 30-weight oil. At highway speeds in summer, under tow loads, or in an engine with higher mileage where those clearances have widened further, the thinner film is measurably less protective. Both substitutions are survivable in the short term. Neither is correct. The part most people get wrong, a 5W-30 in a 0W-20 engine, is not giving that engine extra protection. It is giving it extra heat. Modern engines with tight manufacturing tolerances generate more internal heat when oil viscosity is higher than design. The oil creates more resistance at the bearing surfaces as it moves through passages engineered for a thinner film. That resistance converts to heat. Heat accelerates additive depletion and shortens the interval before the oil's protective chemistry loses effectiveness. The 0W-20 specification was not chosen to cut costs. It was chosen because the bearing tolerances in those engines, often machined to clearances tighter than engines from 15 years ago, were designed around a thinner film providing the correct hydraulic barrier. 5W-30, by creating drag in those passages, causes real energy loss and higher operating temperature. That elevated temperature shortens oil life faster than anything else. The GF7 certification standard, introduced for the 2023 model year forward, covers both grades, but not identically. GF7A covers 0W-20, 5W-20, and 5W-30. Both Pennzoil grades carry the certification, but the performance test that matters most for thinner oils is the aged oil sequence, which measures protection not just when the oil is fresh, but after the equivalent of a full drain interval under thermal stress. The concern specific to 0W-20 is that a fresh oil at the correct viscosity can drift toward the bottom of its allowable range after sustained heat exposure. A 0W-20 that has been in a turbocharged engine through 5,000 miles of highway driving with multiple hot shutdowns is not behaving identically to the same oil on day one. The GF7 standard sets a performance floor at the end of the interval, not just the beginning. We do not have enough controlled used oil analysis comparing these two grades across complete intervals in the same engine to say definitively which degrades faster under identical conditions. The individual data points exist, but the controlled comparisons do not. The 5W-30 is not the heavy-duty option, and the 0W-20 is not the economy option. They are two different engineering answers to two different sets of engine tolerances. The engine built around 0W-20 was designed with the assumption that 0W-20 is in it. The protection specification was written with that oil film in mind. The engine built for 5W-30 was built the same way. Pennzoil produces both grades to the same quality standard. Which one protects your engine is not a question of which product is better. It is a question of which number your manufacturer printed in the owner's manual and why the engineers who designed that engine chose it.